please welcome Dr. Rob Walker.
Good morning. Did everyone fully recuperate from yesterday? I see people shaking their heads. No? Did the music help though? Because my cue music, you may have noted, was not exactly the same that we used yesterday. Right? It was not as loud. Because that piece, every single note, was composed by AI. And sure, that AI composer studied other music, studied other composers. But so did Vivaldi. And I'm not a classical music expert, but I believe that that was convincing. But don't take my word for it. A very similar piece a while ago fooled a whole auditorium of highly esteemed music critics, and they were ecstatic to hear about this newfound masterpiece. So it looked like that was a good show for AI. But we all know music, and especially classical music, is really like nice-sounding mathematics, right? So let's try something different. For one of these paintings, no gentleman ever posed. And one of these male subjects never lived, and no human painter ever portrayed him. So one of this is done by AI. And I'll take this one out, the master himself, Rembrandt, because it's a famous painting and I think you'll recognize it. But which one has been generated by AI? And I'm making air quotes because I wonder if I should just have said painted. And granted, PegaWorld is not the conference for art critics, but I suspect some of you may not pick the actual AI painting out of this lineup. But let me make it a little easier. Only 2 left. Can I do a little test? A show of hands? Who believes the one on the left is the real Rembrandt? Okay, and who think it's the one on the other side? Interesting. Well, for educational purposes, and because I can't see you very well, I will call it even. Because if I call it even, then what I've just done is sort of, you suspected this probably, I've done like a Turing test. And I'll talk about Alan Turing in a moment, but the gist of it is that if an audience is confused about which is which, then we're essentially saying that this AI passed the Turing test, at least as far as painting Rembrandts is concerned. So which one is it? I'll get back to that. Let's talk about this fine gentleman first. Alan Turing. So Alan Turing died in 1954, died tragically. I'm sure many of you have heard the story. But he realized early on that there would be endless debate about what is artificial intelligence and what is original intelligence. Because philosophically, it's always a little tricky to assume that some human-like robot is not actually human. For all you know, I may be a Pega 8 keynote robot, and the real Rob Walker is still sleeping off a hangover. Maybe it's Pega 9, or maybe it's Pega 7 and it already happened. But Alan Turing stated that if a group of people, like yourself, was confused or could not decide if they were talking to some seemingly intelligent entity, which was the machine and which was the human, if that was the case, then that distinction was essentially meaningless. So maybe that computer just pretended to understand music, just pretended to understand art. But if it can pretend that all the time, under all circumstances, no matter how deeply it is probed, then maybe, it actually does understand. So, some people are worried that AI is soon going to pass this Turing test. But I heard someone say, and I thought it was an interesting thought, that we really shouldn't be concerned if a computer is passing the Turing test. We should be concerned if it pretends to fail. But it looks like, at least to me, it looks like AI at least, is somewhat convincing in faking artistry. But let's talk about emotions. This is Pepper, and Pepper specializes in empathy. It's an empathy robot. But don't look at the robot, look at the girl. I'm not trying to trick you, the girl is on the right. But look at her face, right? She is convinced she's talking to someone who is alive, or something that is alive. And that's because Pepper is really smart about, interacting around emotions and things like that. So that's very convincing to her. And that's before robot starts looking like this. This is Sophia. And Sophia, not only does she start looking like a human a little bit more, but also she can pick up on emotional cues in someone's voice. So let's hear it, so to speak, from the robot's mouth, and let's see her when she's doing an interview. Can we roll the video?
I mean, what emotion do you feel being awake and alive?
Curious. Are you curious to be alive?
I am. And are you happy to be alive?
Your tone implies I should be happy. But I haven't been alive long enough to decide.
I mean, did you see how she picked up on that, emotion, and therefore the meaning behind the question? So this is, I think, small baby steps towards the Turing test, perhaps. But we shall see. But let's go back to Pepper for a moment. So as I said, Pepper is a Japanese robot specializing in emotions. And the way she does that is by having this mental map. And when she interacts with people, it changes. So this is an example. So in case you're not wearing your instant translation lenses, or you didn't download your Japanese dictionary this morning, I will tell you that this is a map of emotions. It's a hierarchy of emotions. And in this case, Pepper is upset. So maybe the audience is not laughing at her jokes, or she doesn't get a good vibe from the conversation she's having. After all, she's an empathy bot. So if she was as expressive as Sophia, she would frown at this point. But here, she's all relaxed and she would smile. The point is, these emotional hierarchies, these mental maps, will get arbitrarily deep and complex. And at some point, pretend or not, these emotions are also going to pass the Turing test. So at this point, you may think, well, this is all cute and interesting. Well, I think Pepper is definitely cute. Sophia, a little scary. But there is a dark side to this. Not everybody agrees that AI is a good thing. Elon Musk is on record as saying it will doom us all. And a while back, another gentleman wrote a brilliant piece, a manifesto, where he described how 3 different technologies are a threat to human existence. It's a brilliant piece. It's called Why the Future Doesn't Need Us, or maybe it is Why the Future Doesn't Need Us. And it was written a few months into the new millennium. And Bill Joy, of course, is the inventor of Java. And I think the manifesto has some flaws, but it's a compelling argument about why these technologies will go rogue on us, turn on us, and destroy their creators. And the first one of those is biotechnology. And Bill Joy warns us against tinkering with DNA and with viruses. He thinks that is scary. And he wrote this a while back, but now we have a search and replace genetic editing tool called CRISPR. And it was the runner-up for the Nobel Prize. And CRISPR is essentially a do-it-yourself home kit for genetic engineering. And Bill Joy is concerned about that, and he calls for government restraints on biotech research. And another technology that he is, not exactly cheerful about, is nanotechnology, nanotech. Now, arguably, that's not as advanced as biotechnology is, but it actually did get awarded the Nobel Prize, and it's making great strides as well. And Bill Joy believes that these nanobots, as they're called, they will escape our control and they will swarm, and if that happens, they will attack us at the molecular level and turn anything organic into something very unpleasant, called grey goo. I'm not making this up, that's what it's called. But anyway, he's afraid of that. And the third one is, of course, artificial intelligence. So let's stick with that one for a moment. So Pekka did, and I'm sure you've seen it or heard about it, a global survey about AI. And what we did is ask 6,000 consumers in 6 different countries a whole bunch of AI-related questions. And it turned out that 1 out of 4 humans, so this survey was not sent to robots, right? So you need to take that out of the equations. They could not respond to this. But 1 out of 4 humans agree with Bill Joy and think that AI will take over the world. That's 25%. And even more of those people believe that AI will and robots will come after our jobs. And just as an aside and on a personal note, I really don't understand why that's the case. Right? Why would we worry if they come after our jobs? I think we should be worried if they come after our free time. Like this. No, but I mean, we do all the 9-to-5 jobs while the robots are playing golf. Or they're sipping the cocktails on the beach while we slave away behind our desks. I think that would be much, much worse. But seriously though, what is Elon Musk afraid of? What is Bill Joy so concerned about? And to tee that up, I'm going to introduce you to Bob Ross. So for those of you who know Bob Ross, you must be wondering where I'm going with this, right? Yeah. But for those of you who do not know Bob Ross, 2 things. 1, the screen behind me is huge, but it's not big enough to show all of his hair. He's very famous for that. But more importantly, Bob Ross was a painter. Maybe not a painter like Rembrandt was a painter, but a painter nonetheless. And he painted on television, and people would watch him paint on television. Because he did that in a very relaxed Zen style. He would be behind this canvas and he would go like, maybe a tree should live here. And then with a few brush strokes, there would be a tree, like everybody could do that. So it's very fun to watch. It's on Netflix and YouTube. It's all over the place. Anyway, the story I'm going to share with you has nothing to do with Bob Ross. It has to do with an AI watching Bob Ross paint. And it will give you a peek inside the mind of an artificial intelligence. And you will see it make all these associations while it's watching Bob Ross. And it will give you a good appreciation of what deep learning is all about. Can we show the video, please?
Yes, yes. Guys. It's really to feel somewhere else. Yeah, what's this? It's just I was better. Price. Yes. But this is really never getting yes. Sure. Sure, I just made it.
Well, ladies and gentlemen, I think what you saw, we're not in Kansas anymore, right? This is not your garden variety if then else rules. There are no rules, right? We're seeing this artificial mind, this alien mind in many respects, have all these, let's call them weird, associations while it's watching television. And this is not the technology that beat us at chess. This is the technology that beat us at Go, which is a more intuitive game. And some may think this is terrifying, or at least disconcerting, and others may think it's beautiful. I have heard both. Although, just on a personal note again, I think if you think this is beautiful without any qualification, that's weird. Anyway, I think we can all agree that few CEOs would have something like this run anything particularly critical in their business. Unless perhaps it was properly supervised. So let's cut to the chase here. How can we control such a thing? Excuse me. How can we control such a thing? How can we make sure that we can trust it? So what we propose is something called the T switch. And the T stands for transparent, but it also stands for trust. And if it's in this setting, what I will call the opaque setting, anything goes. So in this setting, we will allow these Bob Ross type of associations to optimize our business. And there will be, as we will see, there will be a place for that. Opaque AI takes the form of these neural networks that we just saw, or genetic algorithms, or ensemble models, a whole bunch of techniques. But what they all share is that they have a very hard time explaining themselves. There is, in a way, no why to their madness. And that doesn't mean they're not effective, it just means it's high risk and likely a liability. So in some areas, like for instance marketing, you can see how some CMO may not care. She may think that if an opaque AI is boosting the return on her budget, on her marketing budget, that's fine. If that opaque AI selects the locations for her billboards or the TV shows for her commercials, or the websites where her ads will play, maybe she's fine with that if it just works. Or maybe not. Maybe she fears that because she doesn't understand it, that it will do damage to the brand. So there is no moral judgment there, right? In some areas, transparency is critical or even mandatory. In others, maybe not. So if we shift this to the transparent setting, now anything opaque will get actively blocked from execution. And we shall define transparent AI as AI that can successfully explain itself to humans. It can exactly explain how it's using data and how it's using that data to make a decision or a prediction. And think about areas like credit risk, where the regulator may insist on transparency, or the impending legislation in Europe around data privacy called GDPR, where companies must be able to explain exactly how they reach a certain decision for their customers. But it's not just about regulation. It's also easily a discussion that veers into ethics and morality. And that's why Pega is committed to implementing this switch in all of our AI software, to give you the choice where to allow opaque AI and where to insist on transparency. What I want to show you real quick is how difficult it is to control opaque AI without such a switch. So this is a random collection of Facebook posts. Well, not exactly random, but you know, you get my drift. And what we're going to do here is trying to predict from likes, from what you like, when you click away on Facebook, certain traits, personal traits, like gender, or age, or sexual orientation, or intelligence, personal things. Can we predict that just from these likes? Well, we can. So forget the small print on the accuracy thing, it's just how good these models are. And this AI, or this algorithm, is basically, the more likes it sees, the better it can predict gender. And this is trending towards 100% accuracy. Same for age, or less tangible traits like openness. And here's a bunch more. Are you a smoker? Race, religion, intelligence. Let's see how it does. These are some pretty solid assessments. And on the less tangible traits, equally. And if you think, well, these bars, you know, the width of these bars, they're not reaching 1, so how good is this really? Well, this is far superior to human judgment. And in fact, to give you an example, let me get my cheat sheet here. This algorithm, if it only sees 10 likes, will know you better than your coworkers. With 70 likes, it will know you better than your friends. With 150 likes, it will know you better than your parents. With 300, it will know you better than your partner. So if you extrapolate that, 700 likes and it will know you better than you know yourself. I'm not kidding, I'm not kidding. You may be in the closet about something or other. It will have figured it out. And by the way, there's nothing on this. I just tried to fail the Turing test here. So the point here is that you cannot control AI through the data. You think you're only feeding it Facebook likes or other small data set, you know, just a few attributes, but it figures out all of these things. So if this is a bank using opaque AI for its lending process, and it's feeding it very neutral data, it thinks, the bank thinks, then this opaque AI can do its Bob Ross kind of thing and become a racist or a misogynist. And the bank would only know when they read about it in the headlines. And that's when it's little data. Now think about big data and how quickly that can go out of control. So what we need is a conscious decision on where to use transparent AI and where to use opaque AI. So first of all, if this is about sort of predicting the next best action, then this is where humans live. It's hard. There is so much data. It's so fast changing. There's so many patterns. AI is just better at predicting things. I mean, some humans, you know, we can keep a few mental balls in the air, and some, if you're like a master chess player, probably a few more, but not tens of thousands. So I would put transparent AI here. And before I put opaque AI on this chart, I want to show you sort of how opaque AI can work in business. Real quick, one example by NASA, another one by Microsoft. So this is an antenna that was designed for NASA by an opaque AI. It needed to be small, but it needed to be powerful, and they used opaque AI to do this, and it worked like magic. It can't tell you how it did it. It can't even tell you why this antenna works, but it works better than any human design. And as far as I know, NASA is still trying to figure out exactly how it works. So this is a triumph, right? A finger-sized triumph in this case, but a triumph for opaque AI. And it's actually using an algorithm that we natively support. Because it's very powerful, we natively support this opaque algorithm in the Customer Decision Hub ourselves. Because it's a powerful thing. But here's another example. Not long ago, Microsoft did a courageous experiment, and they put a tweet bot just on the internet called Tay. And Tay was using deep learning. And deep learning, as I said, is one of the notoriously opaque algorithms. And it started out all pleasant and polite, but real quick, she got completely corrupted by the internet. And I had to look hard, very hard, to even find tweets that I could safely put on this huge screen, because it got bad. It got really bad. So this is where she started screaming at people. And then a little later, she became completely racist and a lover of genocide. But it shows you the risk. It may take Microsoft a while to figure out exactly how it happened. Like, it may be difficult to exactly figure out how a human racist came to his or her convictions. Similar thing. But what if this thing, this experiment by Microsoft, what if it had been a deep learning customer service chatbot? That would have been an unmitigated disaster. So with that, I think, let me quote Bob Ross here, this is where opaque AI should live. So it's more powerful, or can be a little bit more powerful, but it's also much higher risk. What if we collaborated? That would be better, right? Then we get better judgment and we can reduce the risk, but only if humans are not second-guessing AI all the time, right? It has to be a real collaboration. And even if you switch opaque AI off, that's one thing, but if you use it, you still need to supervise it. Otherwise, this is an unacceptable risk. Let me show you real quick how this works. So in the Customer Decision Hub, with the setting switched to opaque, anything goes. So we have neural networks, we have all sorts of opaque things and transparent things. And this is the real switch. So it's not binary, that's just keynote talk. This is a switch that goes from 1 for very opaque to 5 completely transparent. So here we have a neural network, very opaque. This is the Bob Ross kind of thing. Here we have a scorecard, which is very transparent. If we switch it, those things get actively blocked. So that's how that switch works. But as I said, that's not enough. We also need to look at our whole QA process when we're talking about AI. So here we have transparent AI, which can exactly explain itself. Therefore, you know immediately if it has acquired some attitude. So basically the process is the same. Testing, we do the performance test, we do approval, we get approvals from business and IT, we execute in the channels, and we monitor for success. All standard. But if it is opaque AI, now the explanations are only approximate at best. So therefore, we need to insert in this process bias tests to see if this AI has evolved some nasty tendencies. And we need an ethical sign-off by a human to make sure that this AI represents corporate policies and brand reputation. So we talked about the risk. Let's talk about the business benefits for a moment. So in this chart, vertical axis is the business value, what I call the rewards. On the right, on the horizontal axis, we have the ecosystem phase. And this is a slide by Forrester. This is their tech radar that came out earlier this year. And if you look at this, then you see that Pega's AI strategy is pretty solid. Out of the 5 of these technologies, we natively support 4. And that's because we're not into hardware. But while we're happy that Forrester is supporting our R&D choices here, AI is really just a science project if you don't operationalize it. And we operationalize these technologies that Forrester identified through the Pega Customer Decision Hub. And we then surface it up inside marketing, sales, and service. And Kareem yesterday showed you examples of that, and there's tons of other examples in the pavilion. But this is what it looks like. It's the potential of AI in any of these areas. So for marketing, for instance, decision management is important. That's true for all of our CRM applications, but maybe not so much speech recognition. In sales, maybe deep learning is a little less important because we need the why, maybe a little bit more than in marketing. And in customer service, no surprise, lots of potential. Now robotics become very important, and so do virtual agents, although virtual agents, according to Forrester, still have a way to go before they become practical and profitable. And for all of these things, we have the switch, so you can allow opaque AI or insist on transparency. So I would like to leave you with a few final thoughts on AI, because we heard about people like Bill Joy and Elon Musk think this is a threat, an existential threat, and it may turn Skynet on us and things like that. Those are not welcoming words, right? The language is not exactly collaborative, and I think that's a mistake. I think there is huge potential for AI augmenting human judgment. If we ever compete with AI as a species, then that AI needs to be a general purpose AI, not an army of specialists. And as it is, this is just wickedly smart business software that will drive unprecedented outcomes. And with the controls that I just outlined, those outcomes will not just be unprecedented, but also safe. That said, AI is stepping into an area that used to be exclusively ours, right? It's not our muscle, it's the mind, it's insight, it's judgment. So it's not weird that we feel a little competitive maybe, or a little defensive. And in that light, we can understand what Will Smith said to the robot in iRobot. This is how I opened the keynote. Can a robot write a symphony? Can a robot turn a canvas into a beautiful masterpiece? To which the robot replies, I think that's fair. Okay, and before I forget, did you figure it out? This is the Rembrandt painted by AI. Thank you very much.